So hello everyone, we shall start with module 2. Majorly in module 2 we are discussing properties of systems, and in details we will be discussing these 6 properties. Okay, so we will be discussing on linearity property, we will be discussing on time invariance property, we will be discussing on memory, also called as dynamicity of the system. We also discuss on causality of a system, we discuss on stability, and we will discuss on invertibility. Okay, at the end of this topic, you will be able to, given a system, you will be able to check whether the system is linear or not. You will be able to check whether the system is time varying or time invariing. You will be able to check whether system has memory or not. You will be able to check whether the system is causal or not. You will be able to check for stability of the system, and you will be able to check for its invertibility. Okay, so in each and every subtopic of these properties, you will be taking up enough examples so that you will get used to it. Okay, and I'll try my level best to convince you the concepts. Okay, so now we'll discuss on linearity property. Any system can be represented in 3 ways. One is in terms of mathematical equation, second one in terms of graphical representation, and the third one, the same graphical representation we can put it in a more abstract form. Let me just tell you. We will consider an example. Y of t is equal to g of t into x of t. So this is a system, one of the way to represent a system, and what's happening in the system I will let you know later. The same system I can represent in terms of graphical representation, which is something like this. I have a system which does some transformation, and inside this curly bracket x of t, the input signal, will appear, and the output what we get is y of t, and this y of t is nothing but g of t into x of t. This is the other way to represent a system, and one more way to represent the system is nothing but transformation of x of t is equal to y of t. This is the third way to represent the system, and transformation of x of t is equal to y of t. And what is y of t? Y of t is g of t into x of t. Okay, most of the time we use this equation to check for linearity property of a system. Fine. To check linearity property, so we need to get 2 outputs. First output is desired output. We shall call it as equation 1, and we need to get system output. In short, I usually represent it as like this: system output, call it as equation 2. When I write S/M, it is actually a system. Okay, desired output if the system is linear, and what is the system output for a given system? If equation 1, that is desired output, is equal to equation 2, that is system output, then the system is linear. Otherwise it is non-linear. Right? Let me just tell you again. So given a system, we will get desired output, we will get system output. We call the desired output as equation 1, we call the system output as equation 2, and if equation 1 and 2 are both are same, then the system is linear. Otherwise the system is non-linear. This is how we are going to check for linearity property of a system. How do we get the desired output and how do we get the system output? I will tell you in my next video.